Good day, learners! Again, I'm Teacher Marian V. Millanes, and today we will have another video tutorial entitled Arithmetic Means and the Nth Term of an Arithmetic Sequence. Here, we need to determine the arithmetic means and the nth term of an arithmetic sequence. At the end of the lesson, you are expected to number 1, solve any missing part in an arithmetic sequence using the nth term or general term of all arithmetic sequences. Number 2, find arithmetic means between two numbers. Remember, an arithmetic sequence is a sequence where every term after the first is obtained by adding or subtracting a constant number called the common difference. As also discussed in the previous video lesson, the nth term or the general term of an arithmetic sequence with first term a sub 1 and common difference d is given by a sub n equals a sub 1 plus quantity n minus 1 times d. This general term of the arithmetic sequence can also be used to find the first term or a sub 1, common difference or d, nth term of a sequence or a sub n, and the number of terms or n of the arithmetic sequence. To understand what I'm talking about, let's have this activity. The direction is to solve the following problems. Number 1, find the 25th term of an arithmetic sequence with a sub 1 equals 12 and d equals negative 3. Since we are getting the 25th term, your n is equal to 25, a sub 1 is 12, and d is negative 3. Using the general term a sub n equals a sub 1 plus quantity n minus 1 times d, let us substitute your given. So a sub 25 equals 12 plus 25 minus 1 times negative 3. 25 minus 1 is 24. Multiply it by negative 3, we will get negative 72. A sub 25 equals 12 plus negative 72. Since the two terms have unlike signs, we need to subtract them. 72 minus 12 is 60. Then follow the sign of the number with greater absolute value. Here, negative 72 has greater absolute value, so we will follow its sign, which is negative. A sub 25 is equal to negative 60. The 25th term of the arithmetic sequence is negative 60. Number 2, find the 51st term of the arithmetic sequence negative 5, negative 2, 1, 4, 7, 10, and so on. Not unlike in number 1, we have value for d. Here, we need to get d. There's another technique by just choosing two terms from your sequence and then subtract it from right to left. So suppose I will use 7 and 10 in the arithmetic sequence. Then from right to left, we will subtract it. 10 minus 7 is 3. So your d equals 3. Your n is 51 since we are getting the 51st term, and a sub 1 is negative 5. By using the general formula again, substitute the given. A sub 51 equals negative 5 plus 51 minus 1 times 3. 51 minus 1 is 50 times 3, and that is 150. 150 minus 5 is 145. So the 51st term of the arithmetic sequence is 145. Number 3, in the arithmetic sequence 9, 20, 31, 42, and so on, find n if the last term is 207. So here we are getting the number of terms n. So the given a sub 1 is 9, d is 11 because from one term to another we add 11. 9 plus 11 is 20, 20 plus 11 is 31, 31 plus 11 is 42. And we will represent your last term as a sub n. A sub n is equal to 207. By using the general formula, we will substitute a sub 1, d, and a sub n. 207 equals 9 plus n minus 1 times 11. We will transpose 9 on the left side of the equation, and at the same time, we will distribute 11 to n and negative 1. 11 times n is 11n. 11 times negative 1 is negative 11. As a resulting equation, we have 207 minus 9 equals 11n minus 11. We will transpose again negative 11 on the left side of the equation. 207 minus 9 plus 11 equals 11n. 207 minus 9 is 198 plus 11, that is 209. By using symmetric property, 11n is equals to 209. Dividing both sides of the equation by 11, n is equal to 19. Number 4. In an arithmetic sequence, find a sub 25 when a sub 6 is equal to 40 and a sub 15 is equal to 103. Given a sub 6 is equals to 40 and a sub 15 is equals to 103. The unknown is a sub 25. The challenge here is that both a sub 1 and d are missing. Can we solve the problem by just using the general formula? Take note of this. If both a sub 1 and d are missing and two terms are given in the arithmetic sequence, use the formula d equals a sub n minus a sub k all over n minus k, where d is the common difference, a sub n is the last term, a sub k is the other given term, n is the subscript of the last term, and k is the subscript of the other given term. Let's go back to problem number 4. In this problem, we need to get a sub 25, but we have already two givens. A sub 6 is equals to 40 and a sub 15 is equals to 103. A sub 15 equals 103 will be your last term. So your a sub n is 103 and n is 15. On the other hand, a sub 6 equals 40 will be the other given term. Therefore, a sub k will be 40 and k is 6. By using the formula d equals a sub n minus a sub k all over n minus k, this is equal to 103 minus 40 all over 15 minus 6. That is equal to 63 over 9. And 63 divided by 9 is 7. So therefore, your value for d is 7. After getting d, find a sub 1 by using any given term of the arithmetic sequence. In this problem, the given terms are a sub 6 and a sub 15. The computed d is 7. Solve for a sub 1 by using any given terms, either a sub 6 and a sub 15. Here, I will use a sub 6. Going back to the general term, a sub n equals a sub 1 plus quantity n minus 1 times d, let us substitute a sub 6. A sub 6 equals a sub 1 plus quantity 6 minus 1 times your d, which is 7. Your value for a sub 6 is 40. Substitute it. 40 equals a sub 1 plus 35. How did you get 35? 6 minus 1 is 5 times 7, and that is 35. Transpose 35 on the other side of the equation. So we have now a sub 1 equals 40 minus 35. A sub 1 is equal to 5. Now we are ready to get a sub 25 by using the general term again. The computed d is 7 and a sub 1 is equal to 5. A sub 25 equals 5 plus 25 minus 1 times 7. 25 minus 1 is 24. 24 times 7 is 168. 168 plus 5 is 173. Therefore, a sub 25 is equal to 173. There are additional concepts we need to know about arithmetic sequence. The first and last terms of a finite arithmetic sequences are called arithmetic extremes, and the terms in between are called arithmetic means. In finding arithmetic means between two terms, there are two things to consider. Number one, if you insert one arithmetic mean between two terms, just get the average. Add the two terms, then divide it by 2. Then you will get the term in between them. Number 2, if two or more terms will be inserted between two terms, we can also use the formula D equals A sub n minus A sub k all over n minus k. Use D to get the terms between the given terms. Let us now insert arithmetic means between two terms in activity number 2. Number 1. What is the arithmetic mean between 28 and 54? Since we are just inserting one arithmetic mean, just get the average. 28 plus 54 is equal to 82. Divided by 2, that is 41. So, the term in between 28 and 54 is 41. Number 2, insert two arithmetic means between 12 and 39. We will put two blanks between 12 and 39. Use D equals A sub n minus A sub k all over n minus k. A sub n is 39, A sub k is 12, n is 4 because 39 became the fourth term of the sequence, and k is 1 since 12 became the first term of the sequence. Showing the solution, D equals 39 minus 12 all over 4 minus 1. That is equal to 27 over 3. 27 divided by 3 is 9. Therefore, the common difference is 9. Let us add 9 from 12 until we get 39. 12 plus 9 is 21. 21 plus 9 is 30. And 30 plus 9 is 39. Number 3, insert 3 arithmetic means between x plus y and 9x plus 5y. In this case, we will put 3 blanks between x plus y and 9x plus 5y. We will still use D equals A sub n minus A sub k all over n minus k. A sub n will be 9x plus 5y. A sub k is x plus y. Your n is 5 since we have 5 terms in the arithmetic sequence now, and k is 1. So by showing the solution, we have D equals 9x plus 5y minus x plus y all over 5 minus 1. Let us distribute the negative sign to x and y. So D is equal to 9x plus 5y minus x minus y all over 4. Now, in the numerator, we will combine like terms. We will combine 9x and negative x, 5y and negative y. 9x minus x is 8x. 5y minus y is 4y. So, we have 8x plus 4y all over 4. Divide each term by 4. 8x divided by 4 is 2x, and 4y divided by 4 is y. So, D is equal to 2x plus y. We will add now 2x plus y from one term to another. X plus y plus 2x plus y is 3x plus 2y. 3x plus 2y plus 2x plus y is equals to 5x plus 3y. 5x plus 3y plus 2x plus y is 7x plus 4y. And finally, 7x plus 4y plus 2x plus y is 9x plus 5y.